So for binary acids, 2 elements, 2 capital letters, hydrogen, and 1 nonmetal. All right? Okay, so these are going to be the only ones that have that hydro prefix. If it doesn't have hydro, it's not a binary acid. Okay, that's as easy as that. Okay, and then when we go to put our nonmetal, we're going to change the ending. We're going to chop off the ending, and we're going to change it to ic acid. Okay, ic acid. So, for example, we have hydrogen and chlorine together. So this would be one that we used to call hydrogen monochloride, right? Something like that, or hydrogen chloride, something like that. So now you are aware of acids. We're going to be calling it what it actually is, and that is going to be hydro. And then we know that that was chlorine. We're going to change the ene to ic acid, hydrochloric acid. Now, just like when we were learning how to do ionic, the same rule applies. If you accidentally chop off the wrong part or you forget to add a certain letter or something like that, but you're at least still putting in that effort of you start with hydro, you end with ic, and you have acid, I'm going to be counting you correct, okay? You should be chopping off some sort of a letter at the end, but if you accidentally put like hydrochlorinic or something, but you chopped off the E or something, I don't know, something like weird like that, you're fine. Okay, just practice, and don't worry about those kinds of details. That comes with experience. All right, writing the formula. So that's how we're going to do our name. Writing the formula, we're going to recognize that it has hydro in the name. Okay, it will have, so if it has hydro in the name, then we're going to be looking at the charges. We're going to be doing cross and drop. So we know that hydrogen will have that +1. The anion will have some sort of a negative charge. Anion, we already talked about, was a non-metal. Okay. We're going to be doing cross and drop, and the charges are going to become subscripts. So the only one that can end up with a subscript is going to be hydrogen. Now, this little statement right here, I want you to cross it out because it has nothing to do with this part with the acids. That had to do with actually bases, and I forgot to move it down to the page. All right, so when we're writing the formula, cross and drop, the H is going to get a subscript if your anion had a charge, okay, like a special charge. All right, so that's binary. All right, so ternary or oxyacids. So these are going to be ones that have more than 2 elements, meaning more than 2 capital letters in the formula. There are compounds of hydrogen and a polyatomic ion containing oxygen, right? So there's that oxyacid, oxygen. Do not use hydro. Don't put hydro with this name, okay? You will never see hydro with those names. If the polyatomic ion ends in 8, you're going to drop the ending, you're going to drop the 8, and you're going to add ic, and then acid. So we see where this can get confusing, right? This one we had to do the same thing, that you had to replace the ending with ic and So the same thing here. The only difference is that hydro, okay? All right, so anyway, if it ends in 8, you're going to drop the 8 part and put ic, acid. If the polyatomic ends in ite, you're going to drop the ite and end in aus, acid, all right? So hopefully that was feeling very overwhelming and confusing because it's a lot of words, and I completely agree with you. So what I need you guys to write, and then we'll go back and look at the examples, is the saying to kind of keep this lined up, right, in our heads. So go ahead and write this statement on your paper. Ic, I ate a humongous bite. Ic, I ate a humongous bite. This little saying, okay, will help you line up in your head. Ix, go with 8. Aus goes with ite. Okay? So I'm going to give you a second to finish writing that one up. All right, so let's look at the examples, then we'll come back down to this. All right, so here we have HNO3. Okay, so HNO3, obviously the H is not part of the polyatomic list. So you guys have your polyatomics right next to you, right? So look down the list. We're going to find the NO3 part. Okay, so look down your list. We're going to find NO3, NO3. So here's NO3 right here. NO3 is nitrate, right? So NO3 is nitrate. It says it on your notes. Okay, so you notice that it ends with 8. Because it ends with 8, we're going to take that part out and we're going to replace it with ic. So nitric acid. Make sense? So we replace the 8 with ic. So ic, I ate a humongous bite. All right. The other example said HNO2. So once again, NO2 was our polyatomic ion. So we're going to look down our list for NO2. NO2 is right here, down here. NO2 is nitrite. So I see that it ends with ite. So I know that ic, I ate a humongous bite, aus is what we're thinking. So we're going to cross out the ite. We're going to replace it with aus. So you're left with nitrous acid. Okay, nitrous acid. Does that kind of make sense what we're doing there? Okay, it's going to come with practice. But you have to slow down. You have to make sure you think it out. All right, it's not terribly difficult, but it is important that you slow your brain down enough to say, okay, ite, so that means it's going to be hypochlorous acid. 8 nitric acid and stuff like that. Okay, by the way, hypo and hydro are not the same thing. They mean 2 totally different things, which leads me to my next thing. This part. Why do we even have 8 and ite? Like, why would chemistry do this? Okay, so when I used to teach AP, they had to come in on day 1 and know all of these polyatomic ions as well as about 40 other ones. Yeah. About 40 other ones, right? And it all came from a simple sentence, which gave them all of their 8s. Their 8s, right? There's that 8 thing again. And then from there, they could use this logic of what 8 and ite actually mean. So what it actually means is, if you look at the difference between these two, by the way, okay, NO3 versus NO2, what is the difference between these 2 polyatomic ions? There's one thing that's different. NO3 versus NO2. What? Yes, it has more oxygens, right? It has 1 more oxygen. So 8 means that it has more oxygens. Ite means that it has less oxygens. Okay, so they would come in with that. And then hypoite means 1 more or less oxygen. Per 8 means 1 more oxygen. Do you guys need to know that? Absolutely not, but I do want you guys to start thinking about this as we start learning about the properties. Because there's a big difference between if it has more oxygens versus less oxygens, because it's going to pull this thing apart when it dissolves in water, and then that's what makes an acid stronger or not. Okay? So just keep this in the back of your head when we start going into the properties tomorrow. Okay? All right, but back to naming. Let's just stick with the basics. So that's everything you need to know about acids. So let's go ahead and look down this page. We have 1 through 12, okay? What we're going to start with is, I'm not just going to say, okay, what is this one, and let's name it. Name it, name it, name it. Because I'm going to slow your brain down for a second. We're going to go through this list. We need to circle all the binary acids. So when we are looking at this top part of the list, we are looking for things that have 2 capital letters, just like we said before. 2 capital letters, right? 2 elements. Okay, so we're going to circle the ones that have 2. We're going to leave the other ones alone, okay? So you can say binary or oxy. All right, so number 1, binary or oxy. We have H and we have Br. This is binary. There's only 2 capital letters. There's 3 letters total, but that's a lowercase r, right? So 1 hydrogen, 1 bromine, that's 2 things. All right. This next one, H2SO4. Is this binary or is it oxy? That is oxy, right? As soon as I said oxy, you're like, oxygen, yeah, that's right. Okay, yeah, exactly. This one has the oxygen, so we're not going to circle that one. Next one, we have H2CO3, binary or oxy? Oxy, so we're going to leave that one alone. Number 4, H2S. Binary, let's circle that. HClO2. Oxy, leave it alone. H3N. Binary, let's circle it. H2SO3. Oxy, leave it alone. All right, good, perfect. So we figured out our binary acids, okay? Down here, when we're looking at names, what is the big difference between the way these things are named? What does this one have that this one does not have in their name? Hint, we wrote it on this side of the paper. Really big. Towards the top. Hydro, exactly. All right, so we're looking for anything that has hydro. So we're looking for hydro, and that will tell us if it's binary, okay? So looking here, we have acetic acid. Is that binary or oxy? That's oxy, all right? Not as obvious, right? There's no, you're like, oh, there's no oxygen. I don't know what I'm doing. When we write the formula, you'll see the oxygen. All right, but there is no hydro, so that one we're going to leave alone. Chloric acid. Oxy, good. Hydrofluoric acid. That one is binary. That had the hydro part. Okay. Sulfurous acid. That's an oxy. And then chromic acid. That's oxy. All right, awesome. So we at least are able to figure out which ones are binary. Yeah? Thumbs up? Awesome. Okay. So now what we're going to do is we're going to be looking through the ones that we didn't circle, right? Because binary, that's pretty simple. It's not too bad. The naming is pretty easy. But when we're worrying about these oxy acids, we got to start looking at our polyatomic list. So make sure your polyatomic list is in a good spot on your desk to where you can look for it, okay? So looking at this, okay, we got to figure out what is this polyatomic. And so for the first couple, I'll probably write the polyatomic name here. But then I'm going to tell you the part that needs to go on the line. All right, so for this, we have H2SO4. So SO4 is your polyatomic. Who is that on our list? Sulfate or ite? Ate. Sulfate. SO4, sulfate, right? So I'm just going to write sulfate just so I kind of know where everything's going to come from. What I'm going to be writing is this last part. So the 8. Okay? Because what do you know that's going to turn into? It's going to turn into ick. Exactly. All right. So if you want to write the ick on the side, you can do that. Okay. All right. The next one we have H2CO3. CO3. Carbon 8. Good. So carbonate. It's up here at the top. Okay. So it ends with ATE. So you're going to end with ick. Number 5. HClO2. So we're looking at ClO2. Down your list for ClO2. What is it? Chlorite. Good. So we're ending with ITE. So what kind of ending is that going to change into? OUS. Yep. Aus. All right. And then the last one, SO3. SO3. What is it? Sulfite. So it's going to be changing into OUS. Okay? All right. So at least we're kind of set. Oh, wow. You guys can't see that in the Sorry, there you guys go. That is not very large on that screen over there. Okay. Are there any questions about how we're grabbing those endings? We're all okay so far? Yeah, for the most part. Okay, let's look down at the bottom real fast. Okay, down here at the bottom. I just didn't, but we're gonna in a second. All right. So here, for acetic acid, so we already said it's an oxy acid. So what you got to start looking at with these names is you got to realize that, okay, we know that we're starting with acete, and then you recognize that we have ick, all right? So the fact that we have ick tells you that what is this polyatomic actually going to be ending with? What is ick connected to? 8, all right? So you're going to be thinking of acete 8. Look at your list. Let's find one that looks like that. You guys see it at the very, very tippity top. Acetate, right? Do you guys see how that's very similar? Okay, so we're going to have acetate. So I think what's going to help you out the most is we'll put the 8s and ites down here. And then we're going to just write out what is that polyatomic ion. So I'm going to just go ahead and write this out right here. -1 charge, okay? So that you know what you're going to be combining. All right, chloric. So ic is telling me that it's going to turn into a what? 8. So we want something that has chlor and 8. Chlor and 8. So do we see chlorate up towards the top? Chlorate is ClO3 with a -1 charge. So we're going to go ahead and write ClO3 with a -1 charge. Okay. Okay. We're going to skip 10 because we don't need that one. Number 11, sulfurous. We're ending in -aus. So what does that tell you the polyatomic is going to end with? Ite. Okay. So we need something that is sulfite. Sulfite, exactly. So you're kind of just like matching them up, all right? So you just got to kind of find them on your list. All right, so sulfite. We're going to have SO3 with a -2 charge, okay? And put those charges there. That way when you go to crisscross, you're ready to cross that one, drop and cross, okay? Okay, chromic acid. So ic is an 8 again. We want something that starts with chrome, ends with 8. So that would be chromate right here. CrO4 with a -2 charge. Okay? All right, so when you go to actually write these formulas, the only extra step that you're doing is you're going to be putting this together with a hydrogen. Hydrogens all have that +1. Okay, easy way to remember that is it's right there on the little chart. Okay, so +1, and then we're going to have chromate, which was CrO4 with that -2. That 2 is going to come across. 1 is going to come across, so you're left with H2CrO4. Okay, and that's your final answer for that one. I should have wrote it up here. I'm sorry. Okay. Where do you need? Okay, right there. Okay. All right. So, I want to give you guys about 3 minutes to try these out. You can work with a partner, and then if you get through some of them, you want to come go check your answer. I'll have them up on the front. But it is really important. It is so important. You will not know that you have questions until you've tried a few on your own. All right. So try it out. See what ends up giving you an issue, because you do have a Schoology assignment later. Okay. I do have one extra set of notes that I have to give to you guys, which is the base part. That's going to take me all of 2 minutes, I promise. So we'll do that after these 3 minutes, all right? But up here at the top, remember anything that's binary, we're going to start with hydro, right? So hydro, we're going to look up what Br is. That is bromine. I'm going to chop off the ene and end with ic, hydrobromic acid. Since we already figured out this one, we know that we had 8. It's going to turn into ic. This one turns into sulfuric acid, no hydro. Okay, so those are your few examples to work with. But go ahead and do this for 3 minutes, and then I'll finish up your guys' little notes, and you're guys are done. Okay? See the answers? I haven't done this with all the classes, so you guys need to be grateful, and I would take down notes. Now, anything like this, where so a lot of things, or stuff that happens, and hopefully you got to see that, the few people that were kind of trying them truly on your own and stuff like that. What you saw was that you said, okay, well, we chop off the ending, we add IC. So you had like something like sulfic acid, right? And that's okay because it was sulfate, so you would think just take out the IC, whatever. But there's a couple weirdos out there that you have to add the extra letters. I'm not gonna count off for that. So as long as you're following the rules, you're fine. But just so you know, there are a few that are kind of weird. So just kind of write them down for today. All right, so this one we said was carbonate. We're going to get rid of the 8. You should have carbonic acid. So carbonic acid is soda, just so you know, the soda that you drink. All right, H2S. H2S. So H2S is a binary, so we're going to say hydro to start off. And then we're going to have sulfuric. There's that uric again, right? Sulfuric acid. So I wanted to point out number 2 versus number 4. They sound the same. Sulfuric acid versus hydrosulfuric acid. It's a little overwhelming, right? So make sure you are noting whether it is binary or it is an oxy acid. All right, that's super important. All right, HClO2. So ClO2 you saw was sulfite. So this means that this is now going to be sulfurous acid. Okay, sulfurous acid. H3N. So this one is this is a binary again, that's one we circled. So that one is hydronitric acid. Okay. And then finally, this last one we had SO3, which we said was sulfite. So we're going to say, oh my gosh, sorry, I wrote the wrong answer. Sulfurous acid for this one. Ms. Vogel's going crazy, so we're going to cross out number 5. That one should have been chlorous acid. I'm so sorry if you copied that down. Okay. So chlorous acid, this one is sulfurous acid. All right. All right, and then down at the bottom, when you guys had to, when you guys had to combine these, you had to crisscross your charges, okay? So for acetic acid, all that we're going to do is we're going to throw an H in front of that. Remember, our H's all have a +1 charge. So the good news about that is that means that you're never going to have a subscript to the side of any of your polyatomics. That's reassuring, all right? The only thing that's going to change is the charge will always be next to your hydrogen. So here we have a -1, so that means it's going to be H and then C2H3O2. That is acetic acid. That's vinegar, okay? Chloric acid, we have our ClO3 with a -1 charge. So that means, again, we're just going to say HClO3. So no special subscripts or anything like that. Hydrofluoric acid, you had to refer to, this is binary, so you know that it has an H. We have to figure out the fluorine part. So we had to remind ourselves, fluorine was in group 17 with a -1 charge. Since it has a -1, +1, we're just going to write it straight as is. So HF. For sulfurous acid, we had SO3 with a -2 charge. What that means is that that 2 is going to come down to the hydrogen. So we're going to have H2SO3. So all of that's coming from drop and cross. All right, the last little part that you need for tonight is the part at the very, very bottom of your page that says metal hydroxide. Okay, metal hydroxide. For a metal hydroxide, the thing that you got to remember for this is that your metals, those are all, so write this underneath the word metal, cations, which means they're going to have those positive charges, right? So positive charges. Okay. You got to remember that we have this little list of all of our positive charges, right? But we got to worry about the guys in the middle. Those are your transition metals. Those are going to be given with those Roman numerals. So you'll have a +1, +2, and then you'll have Roman numerals. Oh my gosh, I can spell. There we go. Roman numerals. All right. And then hydroxide, if we look at our polyatomic list, hydroxides are right here, right? That's OH with a -1. Okay, so an example of one that has the Roman numerals is going to be something like this: copper 2 hydroxide. If you have copper 2 hydroxide, what that means is that the copper 2 is going to be Cu with a +2 charge. Hydroxide is at OH with a -1. Okay, we will crisscross, cross and drop. You end with Cu OH with a little negative, or little 2 on the outside. All right? So good news again. Hydrogens are a +1, so you don't have to worry about those ever tossing a subscript to the outside. And these, you never have to worry about hydroxides doing that. So basically, anytime you have a subscript with a transition metal, that is the charge. That is the Roman numeral. Okay, so it's something that you can kind of rely on. All right, so that's it for the notes. So like I said, you do have a Schoology assignment that I do want you guys to